Right, so in this clip we're going to work through the solutions to progress check number 3. As with all of these progress checks, we're using the following grade boundaries. So in order to get at least an E, you need to score 19 out of the 80 marks that are available. More than 30 marks will get you into the D, more than 40 into the C, and anything above 52 means that you're working at a grade B level. So just to give us an idea about where we need to get correct answers in order to reach these zones. So if I get a running total going here, if I get to the end of question 1 and it's all right, I get 3 marks. By the time I get to the end of question 2, I've got 6 marks, 10 marks, 14 marks, 24. So if I get everything right up to the end of question 5, that means I'm grading, I'm getting an E. Question 6 takes me to 35 marks. So if I'm getting everything right up to this point, I'm now into the D. 35, 38, 45. So at this point, I've earned enough marks for a C. So that's the end of question 8. 52, 56. So once I get to this point, if I had everything right, I wouldn't have to do anything else and I'd be on for a B. 65, 72, 75, 78, 80. So the critical thing for getting a grade C is that you're maximizing your marks in those first 8 questions, and then if you're aiming for a B, you're maximizing your marks in the first 10, and then every mark you gain after that is just reinforcing how you're doing. So this is a paper 1 paper, so these questions are all written with the intention that you don't use a calculator. Question 1. Marcus is a farmer. He has his own conversion graph to change from acres and square yards. So you can see here the graph that he's using, and it's got a really complicated scale. Complete each of the following statements. 3 acres is equal to blank square yards. So the acres is the horizontal axis, and we need to use that to read off the vertical axis. Now, because this is such a horrible scale, it would be better if we just use the measurements or the points that are already plotted on there rather than extending it. You could extend it to 3, but you'd have to work out what that value there is. So what we're going to do here in order to work out 3 is to work out what 1 is, which is 4840. Okay, so if we show that on the graph, it's always worth you in an exam demonstrating by drawing on the graph. So 1 acre is 4840 square yards, and I can also read directly off 2 acres. Is 9680. So 3 acres I get by adding them together. 0, 8 and 4 is 12. The unit down, carry the 10. 8 and 6 is 14, and 1 is 15. The unit down, carry the 1, and then 14520. So that's one way of doing it. It's not the only way. You could have taken the 1 acre and multiplied it by 3, and that would have got you the answer as well. 5.5 acres is equal to blank square yards. So again, what we want to do is to use the figures that we've given. We already know what 3 acres is. So if I can work out what 2.5 acres is, and that is plotted on the graph. So 3 acres is 14520. 2.5 acres is this point. One, two, one. So 5.5 I'll get if I add those together, which means I'll get the equivalent if I add the square yards together. So 26620. Okay, so for that one you get just the 1 mark, which I'm looking for, which is a B mark. I'm just looking, have you written down 154520? I don't care how you've got it, that will get you the B mark. With part B, there's a method mark, and the method is for using whatever system, correct system you have for finding 5.5. So you could have multiplied that by 5.5 for 1. You could have taken 1.5 and added it to a different combination and so on. So the method mark is for how you've done it, and then the answer mark is for getting the correct answer. So 3 marks for question 1. Question 2. Ellery and Yvonne are sisters. They both live at Cwm Uchel. They do not go to the same school. The graph represents each of their journeys to school and back. So the dotted line is Ellery's journey, and the full line is Yvonne's. And the graph is showing distance they've travelled from home and the time of the day. So at what time did Yvonne arrive home from school? So Yvonne is the solid line. So she leaves home there. She travels that distance of 6 kilometers, and she remains at 6 kilometers until this point when she travels back to school. So what we're interested in is what that point there is in terms of time. Now, if we work with the scale that we have here, halfway between 14 and 16 is 15. So the 3 o'clock point is going to be halfway, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 15. And we can see then at that point it's halfway again, so it's going to be 15:30. B. Ellery cycles along a straight road to school and back. How far does she cycle when going to school and back in one day? So we're with Ellery this time, which is the dotted line, and we can see that she gets to school there, which is 8 kilometers, and then travels 8 kilometers back in the evening. So in one day she's traveled a total of 16 kilometers. Part C. Martha looks at the graph and says, the school Ellery attends is 2 kilometers from Yvonne's school. Is this true? Could be certainly true, certainly false, can't tell. And we need to give a reason for the answer. And this question was, I'm not surprised, really badly answered by candidates across Wales. Because when you look at the distance time graph, there's a clear 2 kilometers gap between Ellery's and Yvonne's journeys. But this is their distance from home. And what you have to be careful of is just assuming that when they both step out of their front door in the morning, they both travel in the same direction. Okay, one of them could step out of their front door and turn left to get to school, and the other one would step out of their front door and turn right in order to get to school. Now, if that was to happen, and they were, so if this is their front door, and then one of them travels, say, 1 kilometre in that direction, she's only walked 1 kilometre. And if the other one travels 1 kilometre in the opposite direction, even though they've both walked the same distance, their school has got a distance of 2 kilometres between it. And that could be the case here. You don't know that the schools are in the same direction. So it's not certainly true, it's not certainly false. You can't tell, and the reason for your answer is the schools may be in different directions from home, or something like that. So that's what they're looking for there. Now, the only advice I can give you is that if you read a question and it seems too obvious, think a bit more deeply about it, because it probably is. So there are 3 marks for that question, and they're B marks. They're just looking for an answer, the correct answer. And for this one, even if you clicked can't tell, unless you put a correct reason, you won't get that explanation mark. So 3 marks for that question. Question 3. Sean wrote the following. For the last 7 days, I have recorded the number of cars parked in my local car park at 10 AM each day. This is what I found. The car park always had some cars in it. The greatest number of cars was 11. The range was 8. The median was 9. The mode was 10. On one day there were 6 cars in the car park. On another day there were 7. Gareth asked, what was the mean number of cars in the car park at 10 AM on these 7 days? Complete Sean's reply to Gareth's question. You must list the numbers Sean recorded and show all your working. The mean number of cars in the car park at 10 AM for these 7 days was blank cars. Right, so there's a lot of information to process there, but you should be recognizing that you're working with averages. You've got means, modes, medians, and ranges. And this is just a context version of the type of question we practice where we've got 5 blank cards and we've got to work out what the number of the cards are. So I've got 7 days. So if I just set up 1, 2, 3, 4, 5, 6, 7, and I'm not going to call them Monday, Tuesday, Wednesday, Thursday. They're going to be the order of the size of the cars. So the car park always had some cars parked in it. So there's going to be no zeros. That's what that one means. The greatest number of cars was 11. So I'm going to put an 11 there. The range of the cars was 8. So the gap between the biggest and the smallest is 8, which means if I take 8 from 11, I get 3, and that tells me the minimum value. So the range was 8. The median was 9, so the middle value was 9. This one's going to be the middle. The mode was 10. So there are more 10s than anything else, which means I must have a 10 and a 10 there. On one day there were 6, on another day there were 7. So those are the numbers of cars in the car park across all 7 days. Gareth asked, what was the mean number of cars in the car park at 10 AM for these 7 days? Well, to work out the mean, you need the total, however many there are, divided by the count. Count is how many days there are. So the total I'm going to add these together now. Okay, so I've got 10, 20, 31, 40, 47, 50, 56. And I'm dividing that by the 7 days. 56 divided by 7 is 8. So the mean number of cars in the car park at 10 AM for these 7 days was 8 cars. The marks for that, there are 2 marks. I'm looking for those numbers. If you get them all right, you get 2 marks. If you get if you get the range right, so if I see 11 and 3 and the 2 10s, you'd have 1 of those marks. You then get a method mark for the total divided by the count, so adding them up and dividing by 7, and an answer mark for correctly getting a mean of 8. So 4 marks for that question. Question 4. Rupert sells shoes online. The designer has drawn a sketch of a new label to stick on the shoe boxes. So it's a trapezium shape. When you see that shape, you should start thinking about area, and you should start thinking about the formula that's given to you on the front of the sheet. She takes the sketch to the printers. The table shows the costs for printing 100 labels. So there you can see we're going to be working with area, and this is the cost for 100 labels depending on their areas. How much will it cost to have 500 of the designer's labels printed? So that's what we've got to make sure. And if you've got a highlighter, and I've been scrabbling around and I can't find one this morning, that's the question we've got to answer. So I would have highlighted that if I could find my highlighter. So it's area. Now when we did the warm-up, the PowerPoint warm-up, I pointed out that I'd forgotten to put the formula you're given onto the front of the exam paper, but this will be given to you in the proper exam, and it's given to you in this form. So if you've got badly drawn parallel lines and you know the perpendicular height between them, so the right angled height between them, the area is, and it's written like this, half A plus B times H. So to find the area, which is the first thing we need to do, it's a half. The A plus B are the parallel sides, so it's not those two because they're not parallel. So it's 10 and 12, and we can tell they're parallel because they've got the arrow notation. And then the H is the perpendicular height. So they've given you a choice of 2 here, but clearly marked the right angled one is the 8. Now although the formula is given like that, we have to put in the times to show that those are being multiplied together. And when you're multiplying, it doesn't matter what order you do that in, but you do have to work out the brackets first. So that's going to be the same as a half. 10 and 12 is 22 times 8. So a half of 22 is 11. 11 times 8 is 88 centimeters squared. So that's the area of one label. So now we have to identify which cost band this label will fall into. So it's 88. So up to 80 centimeters squared is that. Well, we're above that. 81 to 85 is £1.25. We're above that. 86 to 89 is £1.50. So the cost for us is going to be this one. This is the cost of 100 labels. I want 500, so I want 5 lots of £1.50. So the cost is going to be £1.50 times 5. Now you need to have a non-calculator technique for multiplying. This is the one I'm going to use in this case. you need to make sure that you're comfortable with whatever method you use. So 5 zeros are 0, 5 fives 25, write down the unit, carry the 10, 1 5 is 5, 6, 7. So 750, I then need to work out where the decimal point is going to go, and it's going to be 2 in, which is going to take it to there. So the cost is going to be £7.50. Go back to the highlighted question. Have I answered the question? How much will it cost? Will cost £7.50. So I'm confident that I've answered that question. So the marks here, there are 2 marks, a method mark for correctly putting in the right values into the formula. So if you've written that, you get your method mark, and then your answer mark is for the 88. Question isn't telling you to write down the units. It's good practice to do so, but there's no marks in this question for the units. And then the method for the second stage in the question is for writing down £1.50 times 5, and the answer is for correctly working out that multiple. So 4 marks for that. Question 5. So this is the OCW question. In this question, you will be marked, you'll be assessed on the quality of your organisation, communication and accuracy in writing. So there's 2 marks for basically setting this out in a way that the examiner can follow clearly what you're doing. There's a lot of information given to you in this question. So Maes Allen camping charges. Tents covering ground area less than or equal to 12 square metres cost £14 a night. Greater than 12 square metres costs £16 a night. In addition to that, every person, not every tent, every person is charged £4 a night. If you stay 5 nights, you get the next night completely free. This means no charge for tents or people on every 6th night. Rodri and Lars are planning a camping holiday, staying at Maes Allen Camping. They're going to take only 1 tent between them. Take a tent covering a rectangular ground area measuring 2.5 by 4.4 metres. And they both stay for a total of 12 nights. Their holiday is just 8 weeks away. They each plan to save £15 per week from now until their holiday in 8 weeks' time. Will the amount they save be enough to pay for their holiday? So this is the bit that I would be highlighting and coming back to make sure that the maths I've done, the final line, answers that question. Okay, so the first thing we need to do is to work out which of these charges are going to be applied for the tent. And in order to do that, you need to know what the area of the tent is. So we need to find the area of the tent. Area of tent. And what we've got is a rectangular tent, which is 2.5 by 4.4 meters. So to work out its area, I have to multiply those together. Again, you need to have a technique, non-calculated technique, for multiplying 2 two-digit numbers together. The most common one that seems to be used is the Chinese method, where you set up a grid with some diagonals, and we'll have 4, 4 there and 2, 5 there. To fill in the diagonals, to fill in the boxes, you multiply. So 4 times 2 is 8, which you write as 0, 8. 4 5s are 20, 2 in the tens part, 0 in the units part. 4 2s are 8, and 4 5s are 20. You then add up your diagonals. 0, 8 and 2 is 10, which we carry over. 8 and 2 is 10, 11, 11. And then we read off the answer in this direction. So without any decimal points, it would be 1100. We need to put in the 2 decimal points. If we think about that, if that was 5 and that was 3, so rounding them, or 4 and 3, rounding them to the nearest whole number, the answer would be 12. So the decimal point needs to go there. So the area of tent would be 11 square meters. So that means it's less than or equal to 12 square meters. So the charge for the tent is going to be £14 per night. Okay, so £14 per night, and they're going to be staying for 12 nights. But because of the offer of those 12 nights, they're only going to pay for 10 of them, because every 6th night is free. So they need to pay, will pay for 10 nights. So cost of tent will be 14 times 10, £140. So that's how much it's going to cost for the tent. They're each going to be charged £4 for every night that they spend for the 10 nights, and there are going to be 2 of them, so they're going to be charged 8. So cost for the 2 of them will be £4 times 2 people times 10 nights. So that's going to be £80. So that's the cost of the 2 of them. So the total cost of the holiday will be £140 plus 80. So £220. Now we need to go back and read the highlighted line. Have we finished answering this question? Will the amount they save be enough to pay for their holiday? And I've got, so the total cost of the holiday is £220. So I haven't finished yet. I know how much they need. I haven't worked out how much they save. So savings, they're each saving £15 a week for 8 weeks. So they're going to be saving between them £30 a week. So 15 times 2 equals £30 a week saved. For 8 weeks. So 30 lots of 8 is 240. So they save £240, they need £220. So to answer the question, will the amount they save be enough? We need to conclude, so yes, they will have enough saved. Have I answered the question? Will the amount they save be enough? Yes, they will have enough saved. I've answered the question. So how do the marks stack up for that question? Well, there's 2 marks for working out the area of the tent. The method mark is for some non-calculator method of multiplying 4.4 by 2.5, and the answer mark is for 11. There are then 2 marks, method marks, for work that leads to the answer of £220. So there's method for working out finding the charge is the correct charge and working with 10 nights and so on, and then there's an answer mark for £220. Then there's a method mark and an answer mark for finding out how much they've saved, an explanation mark for their conclusion, and then the OCW, 2 marks available there, one for explaining what you're doing, so it's not writing a story, it's just basically saying, right, well, I'm working with the area of a tent and I'm finding that. I'm working out how much it's going to cost them per night. In this part I'm working out how much they've saved, and also being consistent with the units. So here I'm working with area, so I've got the meters squared. Here I'm working with cash, so I've got the pounds currency symbol. So that's where those marks come from. Total of 10 marks for that question. So if we go back to our starting point, once we get to here, we know we're grading. Okay, at that point, if I get that all right, I'm into my E grades. Question 6. A badge is made using a metal button, a pin and a sticky tape. The metal buttons come in packs of 42 and each pack costs £2.50. The pins come in bags of 24 and they cost £1.10. And the sticky tape, which has got 60 centimetres of sticky tape on, costs 52 pence. Elwyn decides to buy metal buttons and pins to make badges, so that there are no metal buttons or pins left over. He wants to buy the least possible number of packs of metal buttons and bags of pins. Show that Elwyn should buy 4 packs of metal buttons and 7 bags of pins. So the most common answer for this, which didn't get full marks, was to work out, well, 4 packs of buttons is going to be 4 lots of 42, and 7 bags of pins is going to be 7 lots of 24, and showing that they were the same amount. The problem with that is that it doesn't show that that's the least possible. In order to show that it's the least possible, what you have to do is list how many what the total number of buttons you'll have for each number of bags you buy. So if we work with buttons first of all, 1 bag or 1 pack is 42. So 2 packs will be 42 and 42, which is 84. 3 will be another 42 on top of that, which is going to be 6 and 126. And then 4 packs, we're going to add 42 onto that, and we're going to get 861. So 4 packs of metal buttons is going to be 168 buttons. Now if we consider pins, so pins, 1 bag has got 24 pins. So 2 will have 48 pins. 3 will have 672 pins. 4 will have 696 pins. So all I'm doing here is adding 24 to whatever that number is there for the next one. So for 5 bags, I'll have 6 and 4 is 10, 9, 10, 11, 12, is 120. 6 is going to be 144. And 7 would be 4 and 4 is 8. 4 and 2 is 6. And 168 pins. So the first time we end up with the same quantity of buttons as pins is when there are 4 and 7. So that's how you show that that's the case. So first time, same number of buttons and pins. So 4 packs, 168, 7 packs, 168. What was the maximum number of badges Elwyn can possibly make using 4 packs of buttons and 7 packs of pins? So a badge is made using a metal button, a pin and sticky tape. So there's only 1 button and 1 pin on a badge. So the most he can make is 168. Each pin is stuck onto a metal button using approximately 2.5 centimeters of sticky tape. Elwyn plans to sell the badges to make the maximum profit possible. How many rolls of sticky tape should Elwyn buy? So he's going to make 168 of them, and each button is going to take 2.5 centimeters of sticky tape. So the total length of tape that we need is going to be 168 lots of 2.5. Okay, so there's different ways of doing this. I'll revert back to the way that most of you seem to be working with multiplication. So each pin, each of the 168 badges needs 2.5 centimeters of tape. So I've got to do 168 lots of 2.5. 2 8s are 16, 8 5s are 40, 6 2s are 12, 6 5s are 30, 1 2 is 2, 1 5 is 5. Add up your diagonals. 0, 10, 5, 6, 7, 8, 9, 10, 12, 2, 3, 4 and 0. So reading that off, I get 4200. To work out where the decimal point is going to go, if that was 3 lots of 170, then it's going to be around about the 500. So the decimal point is going to go there. So the total length is going to be 420 centimeters. Elwyn sells, oh sorry, I haven't answered this yet. So that's the total amount of tape he needs. The question is asking how many rolls. So there's 60 centimeters on a roll. So the number of rolls of tape, I want to see how many times 60 fits into 420. Well, that's the same as 6 into 42, which is 7 rolls. Elwyn sells all the badges he makes for 50 pence each. Calculate the maximum profit he would make. Okay, so I need to check back to make sure I answer that. Well, he sells all of them for 50 pence each. So money in will be 168 lots of 50p. Well, 50p is half a pound. So in pounds, it's going to be half of that, which is going to be 84 pounds. So coming in to this business is 84 pounds. Now we've got to work out the total cost of making those 168 badges. So money out, 7 rolls of tape. So the tape is going to be 7 lots of 52. So 7 twos are 14, 7 fives are 35, and 1 is 36. So that's going to be £3.64. So it's £3.64 on tape. The buttons, 4 packs of buttons, and each pack costs £2.50. So that's going to be 4 lots of £2.50. Double and double again, so 2 lots will be a £5, 4 will be £10. And then the other cost is for the pins. So the pins cost £1.10, and he's buying 7 bags. So that would be 7 lots of £1.10, which is £7.70. So the total money out, the total he's got to spend on these badges is going to be the sum of the buttons, pins and tape. Now, I didn't leave you much space for all this maths, I'm afraid. If that happens in the exam, what you should always do then is go, and at the back there will be a space for you to continue. So for this one, we put it down as question 6 part B, and the examiner will pick this up then. Total money out will be £10, £7.70 and £3.64. £3.64, £7.70 and £10. 4, 7 and 6 is 13. Unit down, carry the 10. 11, £21.34. So the total he spends is £21.34. And if we go back, he makes £84, or he earns £84. So the maximum profit he would make is the difference between what comes in, £84. So profit will be £84 less what he has to spend on the badges, £21.34. So then whatever method you have for performing that subtraction, usually I tend to see this method where that needs to become a 10, which means that needs to become a 10, which means that becomes a 3, and that becomes a 9. So you decompose across the top, leaving you, so you're writing it as 83.910. 4 from 10 is 6, 3 from 9 is 6, 1 from 3 is 2, 2 from 8 is 6. So the maximum profit is £62.66. So that's a big question there, but all you're doing is working with arithmetic. So let's see how the marks are awarded. So in part A, there's a mark if I'm seeing the lists of numbers. So 1 pack, 2 pack, 3 pack, showing that that's the case. And then showing that they are the maximum. If you had just done 4 times 42 to get 168 and 7 times 24 to get 168, you'd have got an SC1, a special case for the site of that. Because you've just misunderstood the question. And then 168 will get you the 1 mark for that. For part B, you need to work out what the total length you need is. So there's a method mark for doing that, and then there's a method mark for working that out into number of rows by dividing by 60, and an answer mark for the correct number of rows. And then for part 2, there's a mark for working out the £84. So if I see £84 anywhere, you get a B mark for that. And then there's a method mark for working out, so to come up with that £21.34 for the total money out, there's 2 method marks for that. And an answer mark for getting the £21.34, and then a final mark for the £62.66 profit. So that was question 6. If we go back to the front, if we manage to get full marks up to that point, we're now earning grade D grades. Okay. Question 7. The diagram below shows a sketch of the existing gas pipes that run to and from Tŷ Gwyn. It also shows a proposed 180 metre gas pipe, which is to be laid to provide gas to Cae Nea. The proposed pipe bisects the angle formed by the existing pipes at Tŷ Gwyn. So these are the existing pipes at Tŷ Gwyn, and they're going to lay this pipeline between it, and bisecting means it cuts that in half. Complete the scale drawing below to show the proposed pipe. You must use a pair of compasses to construct the angle bisector. So if you don't, if the examiner can't see the construction lines, then you won't get that mark. Use a scale of 1 centimetre to represent 20 metres. So not only are we going to draw a pipe, a line like that, but it has to be the correct length, which is 180 metres using this scale. So the length of pipe will be, I've gone onto red pen by mistake, so 188 metres, which I have to shrink using a scale of 1 centimetre represents 20 metres. So it's going to be a 9 centimetre line that I'm going to draw. But first of all, I need to bisect that angle. To bisect an angle, you put your compass point on the intersection of the 2 lines that create the angle. So the compass is going there. I need to draw part of a circle across the angle, and then move the point to where that crosses each side of the angle. That is what the examiner is looking for. If it doesn't see that, even if the angle you produce is correct, the line you produce is correct, you won't get the marks. They'll assume you've used an angle measurer. So my line has to go through the construction and the corner of the angle, and it also has to be exactly 9 centimeters long. So if you see there, I've put the 9 in the corner, so my line is going to go up to the 0. So that's what they are looking for 3 marks. And the way those marks are given is there's 1 mark if the line that you draw is 9 centimeters long, regardless of how you arrive at its position with the angle. And then there's 1 mark for the correct construction, and 1 mark for then drawing the line correctly using that construction. So 3 marks for that. Question 8. Ysgol Fron Isa and Ysgol Caerwen are 2 very different high schools. One school is large and in a rural area. The other is a small school in a town. The town in which the small school is situated has many traffic-free cycle routes. All of the pupils in years 7 to 10 were surveyed in both of these schools. They were asked the following questions. Do you cycle to school? Yes, no. If you answered no, would you like to cycle to school? The results were displayed in graphs as shown below. So the black parts of the bars show the percentage of pupils, not the number of pupils, the percentage of pupils that cycle. So this particular section here is telling me that in Ysgol Fron Isa, 40% of the year 7 students cycle to school. The grey part, which is between 40 and 80, so those 40% of students in year 7 would like to, and there are 20% of year 7 students in Fron Isa that don't have any view on cycling. So that's how the graphs are displayed, and the same here for Ysgol Caerwen. Which school and year group has approximately equal split between the 3 categories? So I'm looking for where the black, grey and white are about the same size, cover the same area. So when I look at the 3 schools, I would say that it's between the 2 year 10s, and realistically that is the one that the size of the rectangles are about the same, pretty much thirds, 30%, 33%. So I'm looking at Ysgol Caerwen, and it's year 10. Circle either true or false for each of the following statements. There are definitely more pupils in Ysgol Fron Isa who cycle to school than in Ysgol Caerwen. Well, even though there are more black, there's greater area covered by black in Fron Isa than in Caerwen, the schools are different sizes. So if that's the small school, there could be more kids cycling in year 10 in this large school than in all of the year groups in the smaller school. So because we're just given percentages and we don't know the size of the schools, we cannot say that. So that is false. Both schools have pupils in each year group with no interest in cycling to school. So no interest is the others, and we can see that every year group has got, in both schools, has got a proportion of white. So that's true. The questions asked were biased. Well, let's go back to the questions. So they were asked all students, do you cycle to school? And if you answered no, would you like to? There's no bias there. If they only asked kids who had bikes, then that would be biased. If they were to use that saying, don't you believe we should be able to, it would be biased. But those questions aren't biased, so that's false. Approximately 20% of the pupils surveyed in Kai Wen cycle to school. So in Kai Wen, we've got 20% of year 7, we've got 20% of year 8, we've got partially less than that in year 9, but partially more of it in year 10. So that balances out that shortfall there. So over the whole school, you would say that that is true. It is more likely that it is Ysgol Fron Isa that is the small school situated in a town. So the small school situated in a town has many traffic-free cycle routes. So you would expect the town school to have more pupils cycling. And the school which has got a larger proportion, I said more, should be a larger proportion of the pupils cycling, is certainly Fron Isa. So that would back up that that is likely to be the case. So that is true. In January 2011, there were 1,200 miles of national cycle network routes in Wales. In January 2016, there were 1,400 miles of national cycle network. If the number of miles of national cycle network routes in Wales were to continue to increase by the same number of miles per year, how many miles of cycle routes would there be in January 2018? So over the 5-year period we've got there, the increase has been 200 miles. So the growth per year could be 200 divided by 5, which is 40 miles. So every year it grows by 40 miles. So by the time we get to January 18, that's another 2 years on, so by January 2018 there'll be the 1,400 in 2016 plus 40 by the end of by January 2017 plus another 40 is 1,480 miles. Why is your answer in part 1 unlikely to be an accurate estimate of the number of miles in Wales in January 2018? Well, there's all sorts of answers you can give for this, but what you're trying to say is that they may have stopped. We don't know whether they finish at this point. All we are doing there is using previous data to assume it builds by an equal amount each year. So assuming an equal amount built each year, which may not be the case. So something like that is what they're looking for. Okay, so marks for that question. So there's 1 mark just looking for the right school and the correct year group. Then if you get all 5 of those correct, you get 3 marks. If you get any 4 of them right, you get 2, and if you get any 3 of them right, you get 1 mark. For part B, there's 1 mark for seeing you working out the annual growth, 200 divided by 5, and 1 mark for site of the 1480, and then here you get an exclamation mark, an E mark, for some form of description that you can't rely on what has happened to predict what is going to happen. So that is question 8, which takes us into the C zone when you look at the marks at the start. Okay, question 9. Stylish computer desk. Made of laminate wood, non-scratch top, length is exactly 2000 millimeters, so that hasn't been rounded. Luke wants this new desk for his bedroom. The desk is to fit on the straight wall between his wardrobe and his bookcase. So there's a diagram of how we want it to look. Luke has measured the length of the wall, which is 600 centimeters, and you can see here that we've given measurements which have been rounded. So immediately that triggers, or should trigger for you, okay, so we're into the sort of grade B work here. This is limits of measurement and error boundaries. So let's deal with each of these first of all. If 600 centimeters has been rounded correct to the nearest 10, that means it could be as large, could be anything up to 605 or as low as 595. Anything in that region, when it rounds to the nearest 10, so like 598 or 603, rounds to 600 centimeters. So that's its maximum value, that's its minimum value. The 147 is rounded correct to the nearest centimetre. So the upper and lower limits on that are going to be anything up to 147.5 and anything as low as 146.5. So if I've got 146.8 to the nearest centimetre, that rounds to 147. And anything up to that point, and we've had this discussion in class, we know that 147.5 actually rounds up, but to give us some boundaries to work with, those are the ones we use. And then the final one is the 250, which is also rounded to the nearest centimetre. So the largest that's going to be is 250.5, and the smallest is going to be 249.5. So those are our extreme limits that we're working with. What is the greatest possible length of the wall? Well, we figured that here, it's going to be 605. So 605 is there. What is the least possible length of the wardrobe? So the wardrobe is the 250, which is this. So the least is going to be 249.5, which is there. Can Luke be certain that his desk will fit in the space available? So the space available is the length of the wall. So the worst case scenario will be if the wall is at its minimum value and all the furniture is at its maximum value. So wall at lost control of my eyes then, haven't I? Minimum length, and the minimum length of the wall is 595. And furniture all at max length. So the furniture is the wardrobe, the bookcase and the desk. So wardrobe maximum wardrobe is 250.5. centimeters. Bookcase is 147.5. And the desk, well, the desk is 2000 millimeters, and there are 10 millimeters in a centimeter, so to turn that into 2000 millimeters divide by 10 would be 200 centimeters, and that's exact, so we don't have to worry about rounding that to maximum and minimum. So if we add those together, we get 5 and 5 is 10, 8, 9, 5, 9, 8. So the worst case scenario is that all the furniture has got a length of 598 centimeters, and the wall could be as narrow as 595 centimeters. So to answer the question, here's the question: can Luke be certain? No, he can't. The max length of furniture, 598 centimeters, is greater than the minimum possible width of wall, which is 595 centimeters. Okay, so let's take a look at how that one's marked. So these are straightforward, 1 mark for each. And then for part C, there's 1 mark if you are using the same units throughout, and the easiest way to do that is to have them all in centimeters. So turning that desk into that is going to earn you that mark. Then there are 2 marks for with the furniture and the wall having the correct extremes, so the minimum wall and the maximum furniture will give you that 2 marks. Then there's another mark for actually then working out the total maximum for the furniture and comparing it with the minimum for the wall, and your last mark is for the conclusion. So total marks for that question is 7. Question 10. A number of paths are to be laid to join 3 new office buildings. A sketch of the architect's plan is shown below. So this, as soon as you see it, with these arrows, triggers angle properties of parallel lines, but also I can see triangles in there, so I know this is an angle property question. The architect has shown a number of angles in his planning for the new paths. Calculate the size of each of the angles A, B, C and D. Okay, so usually the order that they're printed is the way in to the question. So that angle there is probably the most straightforward one to work with. Now I can see I've got parallel lines, and when you're working with parallel lines, you know that where you have a line that intersects a pair of parallel lines, so if I've extended those, then that intersecting line moves my angle knowledge from there down to there. So if I know that that is 67, the Z is what you tend to look for first. If that is 67, so is that. Then I've got a straight line. So A is going to be 180 less 67. So that's going to be 113. So A is 113. So that's one pair of parallel lines. Then over here I've got another pair of parallel lines. I've also got an intersection there. So that angle there and the angle opposite it on the intersection are the same. So I know that that is 72. In my Z there, if that is 72, so is that. So to work out B, which is on a straight line, it's going to be 180 take away 72, which is going to be 108. Okay, so then I need to find C. Right, so to find C, what I have to be careful of now is that in this part I haven't got any parallel line information, but I do spot I've got a straight line and I'm in a triangle. So if that's 72 on a straight line, that's going to be 108. So to work out what this angle here is, 108 and 21 is 129. So this is going to be 180 take away 129, because angles in a triangle also add up to 180. So write that as 170, 10. 1, 2 from 7 is 5. So that one there is 51. Those are directly opposite each other, which means if that's 51, so is that. And then I'm back on a different pair of parallel lines with a different Z, where C and D are the same. So that's how you go figuring out that particular group of confusing parallel lines. 4 marks, 1 for each of those. Question 11. Myrion's window cleaning business. No job too small. Myrion is a window cleaner. From Monday to Friday, he records how long he spends cleaning windows for each of his customers. He draws a cumulative frequency diagram to display his findings. So cumulative frequency is not a complicated thing to revise. You can usually revise it in about 15-20 minutes. You know that the maximum value recorded is what the total data is out of. So in this case, we've got 120 customers. Part 1. Use Myrion's cumulative frequency diagram to find the median and interquartile range of the times he spends cleaning windows for his customers. So the median is the middle of 120 is 60. So on my cumulative frequency graph, I'm going to show the examiner by marking on it median, and then carefully reading down. I want to read that off. I need to know what the scale is. It's going from 0 to 5 in 10 jumps. So each square is half a unit. So 15, 16, 17 minutes for the median. And then the upper and lower quartiles are what we need to find the interquartile range. The lower is halfway, or is a quarter of the data, so halfway between 0 and 60. So I need to correctly get 30. 2, 4, 6, 8, 10. So the lower quartile will be here. Which would be 14. So the lower quartile equals 14. The upper quartile will be halfway between 60 and 120, which will be 90. 2, 4, 6, 8, 10. So the upper quartile is at 19. So the interquartile range is the difference between 19 and 14, which is 5 minutes. Myrion looks back at his raw data. He finds that the median is actually 17 minutes 30 seconds. Why is there a difference between the median from his cumulative frequency diagram and the actual median from his raw data? And the reason for that is that when we're working with a cumulative frequency diagram, we're estimating. We've lost the raw values. The data has been grouped. So the reason for that is the data on the diagram has been grouped, so will only be an estimate. And that's the same when we work with the mean of group data. Because we've lost the original amount of data, so the original data values, then it's just an estimate. Part B. Myrion is looking at the time it took to clean individual customers' windows. Find the number of customers whose windows took between 10 and 15 minutes to clean. So now we're going in the opposite direction here. So between 10 and 15 minutes. So here's 10 minutes. So the number of customers that he cleaned in less than 10 minutes is 2, 4, 6, 8, 10, 12. And in 15 minutes, it's 34. So the number of customers that he cleaned between 10 and 15 minutes is the difference between 34 and 12. So 34 take away 12 is 22. So 22 customers. Myrion thinks that for approximately 80% of his customers, he cleaned their windows in less than 20 minutes. Is Myrion correct? So 80% of his customers would be 80% of 120. So 80% of 120. 10% would be 12. So 100 would be, so 80% would be 12 eighths, 72. So Myrion thinks that he cleans approximately 72 customers in less than 20 minutes. Now if we look at his graph, in less than 20 minutes, he cleans 102. Sorry, 12 8 to 96, aren't they? So that's 96 customers. Okay, so he thinks he's cleaned 96 customers. His graph is saying he's cleaned 102. So 102 customers in less than 20 minutes. So that's approximate enough, so yes, so that's true. Yes, he did. 96, 102, not a huge difference. Okay, so marks for question 11. For 11A, 1 mark for the median, a method mark for finding upper and lower quartiles and subtracting them, and your answer mark for 5. There's an explanation mark for the second part, and then for part B there's the method mark for finding both values and subtracting, and an accuracy mark for getting the right answer. And for part C there's a method mark for working out what 80% of 120 is. There's a method mark for reading 102 off your graph, and then there's an accuracy or an answer mark for your conclusion. So total marks for that question 4, 6, 9. Question 12. Gwen recorded the time she spent writing each of 240 text messages. She finds the following. The greatest time is 1 minute 5 seconds. The range is 60. The median is 45. The lower quartile is 23. And the interquartile range is 32. Use the graph paper to draw a box and whisker diagram to represent Gwen's data. So let's just remind ourselves, and there's no harm in doing this on the page. More often than not, they give you box and whisker diagrams to interpret, but every so often they'll get you to draw one. So the parts of the box and whisker plot, that is the minimum value, that is the maximum value. The distance between those two will give you the range. The lower end of the box is the lower quartile, the upper end of the box is the upper quartile, and the distance between those two lines is your interquartile range. The line inside the box is the median. So that's what we have to produce. Everything here, apart from the greatest time, is in seconds. So I think the first thing we should do is to write 1 minute 5 seconds as 55 seconds. 65 seconds, sorry. So that's going to be my maximum value. If the range of the times is 60, then that means the gap between the maximum and the minimum is going to be 60, which means my minimum value is going to be 5. The median is 45, so that value is going to be on the 45 point on the axis we draw. The lower quartile is 23, and the interquartile range is 32. So the upper quartile is going to be 32 on from that, which is going to be 55. So that's what we need to draw. So first of all, we'll draw our axis. We'll start with 0, and it needs to go up to 65. So this isn't really clear graph paper, is it? So if we go up, let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. So that was riveting to watch. This is going to be our time axis, and it's going to be in seconds. 10, 20, 30, 40, 50, 60. These go up to 65, so that works. The minimum value is 5. Now where we draw this box doesn't matter, but it would be nice to have it kind of symmetrical. So what I'm going to do is, if I put a little marker there, that's going to be my lines, and then I'll go above and below that. So my minimum value is 1, 2, 3, 4, 5. So that's that point. My first line of the box is at 23. 20, 21, 22, 23. And my box, I'm going to make 10 squares, so 5 above, 1, 2, 3, 4, 5, 5 below, 1, 2, 3, 4, 5. How wide that is really doesn't matter. What's important is where these lines are in relation to the axis you draw. Then I've got the median, which is at 45. Which is 1, 2, 3, 4, 5. So there. Then I got my upper quartile at 55. 1, 2, 3, 4, 5, which is there. And then my maximum value. I'll just draw the box first. At 65, which is 1, 2, 3, 4, 5, there. So that's it. That's your box and whisker plot. So there's 5 marks for that. So how are those awarded? So there's 1 mark for the scale, going from 0 to 60. There's 1 mark for just having the right parts of the box and whisker. So just purely having its shape will get you a mark. Then there's 1 mark for the 5. 1 mark for the upper quartile at 55. And 1 mark, the last mark, is for a combination of having the maximum value in the right place, the lower value quartile in the right place, and the median. So total of 5 marks. Oops, sorry, I haven't done the second part. How many of these text messages took Gwen more than 23 seconds to write? So the other fact about a box and whisker plot is that each section of it represents a quarter of the data. So a quarter of the data happens between 5 and 23, a quarter of it between 23 and 45, a quarter between 45 and 55, and a quarter between 55 and 65. So more than 23 seconds is going to be 3/4 of the 240. So more than 23 seconds, because 23 seconds is that lower quartile value, would be 3/4 of 240. Well, 1/4 of 240 is 60, so 3/4 will be 180. Don't know why I wrote 150 there. So 1/4 is 60, 3/4 would be 3 lots of 60, which is 180. And there's 2 marks for that. 1 mark for the method, 1 mark for the final answer, 7 marks for the whole question. Question 13. A flower bed is in the shape of a semicircle with diameter 20 feet. So semicircle, diameter is the distance all the way across. Taking pi to be approximately 3.14, calculate the area of the flower bed. So you need to know and recall the area of a circle is pi times the radius squared. If the diameter is 20, the radius is 10. They're telling you to use pi as 3.14 times the radius squared. When you're squaring, you multiply by itself, so that's 10 times 10, which is 100. When you multiply 3.14 by 100, well, 3 lots of 100 is 300, so that's going to be 314. But that would be for a full circle. We've got half a circle. So we've got 314 divided by 2, which is going to be 157 square feet. Question isn't asking you for the units, so there's no marks for writing it down. There's a method mark for the pi r squared and putting the values in. There's an answer mark for your 314 and a final mark for correctly dividing by 2 because it's a semicircle. So 3 marks for that. And then we come to the final couple of questions. So these are grade B percentage questions. Cassidy invests £4,000 into an account that pays 2% compound interest per annum. So that's every year. She does not make any further payments into her account. She does not draw any money from her account. How much will Cassidy have in her account after 2 years? So that's the question we've got to answer. If a compound percentage question comes up on a paper 2 where you're allowed to use a calculator, there's a very different method you would use. But this is a non-calculator question. So in the first year, she earns 2% of £4,000. Well, 1% will be dividing that by 100, so that will be £40. So 2% is £80. So for keeping the money in the bank account for 1 year, they're going to pay her 80 quid. So at the end of year 1, in her account, there will be the 4,000 she paid in plus the £80 they've given her. So when she keeps it in then for a second year, they're not going to be paying her 2% of the 4,000 because there's more in her account. So they now work out 2% of that value. Common mistake to make with this question, and a few of you made it, was you just doubled that. So 2%, first of all find 1%, which will be £40.80, divided by 100. So 2%, double it, which will be £81.60. Check the question. How much will Cassidy have in her account after 2 years? Have I answered it? Not yet. So in her account, she's going to have the 4,080 that she started the year with, plus another £81.60. So she'll have £4,161.60 in her account. So 3 marks for that. 1 mark for working out how much is in after the first year. The second mark is for working out the method of how much she's got in her account at the end of the second year, and an answer mark for the correct total. You need to check that because sometimes the question will ask you how much interest has been earned, in which case you take off the original quantity of 4,000 and the answer would have been £161.60. Question 15. So we're at the back end of an intermediate paper, so if you've got percentage questions, they're grade B, they're not going to be straightforward. Logan buys a coat in a sale in which the coat has been reduced by 40%. It's been reduced by 40%. He pays £54 for the coat. So that's after that reduction has been applied. How much was the original price of the coat? So the first thing is to find the multiplier. The original amount is 100 and it's been reduced, so he's paying 60% of the original value. So 60% of the original, which we don't know, is going to give us the £54 he paid. I want to find out what that is. Again, on a paper 2, we worked with a different method for doing this. So if 60% is 54, I want to find out what 10% is. To go from 60 to 10, I've got to divide by 6. If I divide that by 6, I have to divide this by 6 as well, giving me 54 divided by 6 is 9. So 10% of the original value is £9. I want to find out what all of it is worth, so I have to find 100% by timesing by 10, which means I have to times that by 10 as well. So 100% of its value is £90. So the marks for that is a method mark for going to 10% and back to 100, and an answer mark for 90. So that's it. That was progress check 3. That was quite challenging. Lots of you found that really difficult. So it's really worth you spending time working through those questions with this video.